Okay, so what I'm going to be going over in this lecture is just a problem set. Now I only have two problems in this problem set. So problem number one, a telephone signal travels through a cable at half the speed of light. How long will it take for the signal to get from New York to Miami if the length of the cable is 1,200 miles? So we're going from New York to Miami, and there's the cable in between. That cable is 1,200 miles long, and we want to know how long will it take for the signal to get from New York to Miami using that cable with the signal traveling at half the speed of light. Okay, so first we need to convert the expression of speed of light from meters per second to miles per second. And so we're going to have to take a look at some conversion factors. And so the velocity of light equals 300 times 10 to the 6 meters per second. And we have 100 centimeters equals 1 meter. 1 inch equals 2.54 centimeters. 1 foot equals 12 inches. 1 mile equals 5,280 feet. Okay, so next, I'm going to set up the equation for conversion from meters per second to miles per second. And so what we have here is that the velocity of light equals 300 times 10 to the 6 meters per second times 100 centimeters per meter times 1 inch per 2.54 centimeters times 1 foot per 12 inches times 1 mile per 5,280 feet. And then when we do all of that, we can see that meters cancels out, centimeters cancels out, inches cancels out, feet cancels out, and all we're left with is miles per second. And that figure that we get here is the velocity of light in miles per second is equal to 186.4114 times 10 to the 3 miles per second. So now that we have that, the signal speed is a fraction of the speed of light. So the velocity of the signal equals 1/2 times the velocity of light. And so that just gives us 93.2057 times 10 to the 3 miles per second. Okay, so that's the velocity of the signal. And so then this rate is used to get the time required for the signal travel. And so we have 1 second per 93.2057 times 10 to the 3 miles multiplied by 1,200 miles, and then that gives us 12.8748 times 10 to the negative 3 seconds. It simplifies to the time required is approximately 12.9 milliseconds. So that is the final answer for problem number one. Problem number two. What is the equivalent rate of dollars per second to pay off $120 billion in 1 year? So first I'm going to determine how many seconds there are in a year. So my conversion factors are set up in this way. And so I have 60 seconds per 1 minute, 60 minutes per 1 hour, 24 hours per 1 day, 365.25 days per year. And when I multiply all of that, as you can see, minutes cancels out, hours cancels out, days cancels out, and I'm just left with seconds per year. And that figure that I get here is 31.5576 times 10 to the 6 seconds per year. Okay, so now that I have that, I'm going to use the seconds per year rate to get the dollar per second answer. Okay, so I have 120 times 10 to the 9 dollars per year. I'm going to multiply that by 1 year per 31.5576 times 10 to the 6 seconds, and then I get 3.8026 times 10 to the 3 dollars per second, which equals $3.80 per 10 to the negative 3 seconds. And that gives us finally our pay per second is going to be at a rate of $3.80 per millisecond. So $3.80 per millisecond, okay, in order for that to all work out. So that is it that I have for these two very short exercise problems, and hopefully this was helpful for you. Thank you for watching, and have a nice day.